All right. So before we jump into material here, we'll have our participation quiz for today. Um, I'll also get that Module 8 quiz posted after class, kind of see exactly how much material we get through. I think we'll be fine. There might be one question on there that I kind of switch out, but based off my other section, we got through everything okay. So I wanted to mention something that I noticed, and I'll put an announcement up about this. That module 5 and 6 quiz, one of the questions, instead of being 1.5, was set to be 1.25 points. So it was making the kind of scores look a little weird. I've got everything regraded in Canvas now so that if you got that question correct, like it basically graded it like it was 1.5. So it updated all those scores. So that should be accurate now. I believe it was question 5. I'll include that in the announcement. I'm also going to post. In fact, I got it up here already. I think it's published. So let me make sure. Yeah. I'll even add it right now so we can see it. So most of all of you answered that 7 out of 7 participation quiz on time. That was the crucial one that had that Respondus lockdown browser. If you didn't, or you had one or two students that had an issue with it based off the device they were using, I've got another test quiz here. Use whatever device you plan to use for the exam Friday to run this test quiz to make sure you can get that lockdown browser working correctly and have it ready to go by Friday. It is your responsibility. I have now made that participation quiz available as well as this test quiz. If you have any issues with that lockdown browser on Friday, that onus is on you, right? You should have this worked out well in advance so that you can make sure whatever device you're using, you've gotten that lockdown browser to work correctly. This is now your second opportunity, which I wasn't planning to kind of use, but given that one or two people had issues with, oh, where was it? This initial one, we're making sure we get all those things ironed out before the exam Friday. Okay, so we'll finish up Module 8 today. That Module 9 reading is due before we start class tomorrow. I'll add in the Module 9 files, practice problems, as well as the slides here after class today. And then you've got those practice exam problems and answer key for exam 2. We'll do Module 9 Tuesday, Wednesday, and then review on Thursday. And then on Friday, we'll have that exam similar to the other one, where you kind of have that 4-hour time block to get on and complete it whenever works best for you. Okay? So we'll eat between 11:15 and 3:15. Okay? I also posted a new version of the Module 8 slides. I just rearranged the order a little bit. So it's the only one that is now currently up there on Canvas. So that's the ones I'll be using today. So we left off thinking about properties of indifference curves. Okay, so we'll kind of run through these pretty quick, and then we'll kind of dive into combining this with what we talked about last week, which was the budget constraint. If there's no other questions, we'll kind of jump in here to material. It should be all the housekeeping stuff. Any questions from me before we start getting into things here today? Okay. We're gonna have to get my pile of markers here. So, don't need them quite yet, but we will. So I introduced the idea of an indifference curve at the very end of last class. So it's kind of similar to our budget constraint, but different in some ways. So it is going to represent, we've got these two goods we can buy. It's all the different combinations that we could buy that would give us the same amount of total utility. So we're not saying we can afford them. We're not factoring prices in. We're just saying, here's different combinations of two goods. We said utility can really represent like total benefit or total happiness of the consumer. So I could, for example, have, I don't know, one home and one car, and I might be equally as happy as if I have 0 homes and 4 cars. I don't know, something like that, right? So, and I say homes, obviously I would need a place to live. Maybe I'm renting a place instead of actually owning a home. So we've got these indifference curves. Every point on our indifference curve will represent combinations of these two goods. So I did Pepsi and pizza here as the example, that give me the same amount of total happiness or the same amount of total utility. So it's going to have to be true is that if I want more of this X good, I'm going to have to give up some of that Y good in order to keep total utility the same. Okay. So I'll kind of go start an example here that we'll use for some later principles as well. But you can kind of think about if I have this indifference curve, and it's the combination of these two goods I can buy. And let's say the level of happiness, we somehow put a value to it. Okay. Well, if the marginal utility of buying one more unit of good X, let's say it would be 60. So maybe I'm currently consuming this amount of X and this amount of Y. If the marginal utility of the last unit of good X I had was 60, marginal utility of Y is 10, well then to get one more unit of good X, how much would I be adding to my total utility? Well, my total utility before was 100. If I get one more unit, the marginal utility of X is 60, so I would have 160. In order to keep total utility the same at 100, how many units of good Y would I have to give up? Well, if each one is worth 10, I'd have to give up a total of 60 units of utility. So what? Minus 6 times 10, right? Would leave me with that total utility of 100. So to get one more unit of good X, in this example, it's not really drawn to scale, I'd have to give up 6 units of good Y. Okay, so this indifference curve is going to be kind of downward sloping, representing that when I want to get more of good X, in order to keep total utility the same, I'm going to have to give up some of good Y. Okay, so not only will it be downward sloping, right? We're also going to say that higher indifference curves are going to represent higher amounts of total utility. So I'll kind of show you off of the slides in a second here why that has to be true. But if I'm at point A, think about it this way. As I go down closer to this 0, 0 point, what's my total utility when I have 0 of both goods? 0. So as I move away from that point, higher indifference curves further away from this origin of 0, 0 would represent higher amounts of total utility. Okay. So we could kind of rank order, say point D, even though I have more of good Y, less of good X, it must be that that combination, I must like Pepsi more than pizza because that's providing me with a lower level of utility than point A is. Okay. So higher indifference curves further away from that 0, 0 point represent higher levels of total utility. Okay. So why would indifference curves not cross? Right? So we're going to kind of prove this is like a logic thing. You can prove something by proving that the proving that the falsehood would not be true, or that the reverse of it is not true. So I'll kind of draw this out. I think kind of give you a slightly different way of thinking about it. Then we'll jump back to the slides. So let's say we've got X and Y. Let's say this is my indifference curve. And this is all the combinations of good Y and good X that provide me with the same amount of utility of 100. If instead I had an indifference curve here, and let's say, okay, I'm going to assume that this indifference curve is telling me that the total amount of utility I have is 200. Okay. Well, that would make sense in that if I was spending out here at this quantity, I've got the same amount of good X, but more of good Y, so I should have more total utility. However, if they cross, that means there's going to be some quantities where I have the same amount of good X, but I actually have less of good Y. How could that result in having more total utility? We're assuming that margin utility at the very lowest is 0, right? We can't have negative margin utility, otherwise we just won't ever buy that good, right? I mean, having a good, right, shouldn't provide you with negative margin utility. So if they ever crossed, there'd be some regions where it looks like, oh yeah, that makes sense that this would be a higher indifference curve. But as soon as they cross, now you have a region where that kind of goes against logic, right? That having the same amount of one good but less of the other, you would somehow have more total utility. That can't be the case, right? Which is why we said that when we're thinking about these indifference curves, higher indifference curves should always represent higher amounts of total utility. Why? Because if it's higher at every point, now no matter what quantity we're looking at, we have the same amount of X but more of good Y. Oh yeah, our total utility should be higher. Okay. All right. So we can't have them cross, right? So, an example like this wouldn't make any sense that, being on point A, another way of thinking about this is if these are providing me the same amount of total utility, all the points on my indifference curve, how could A be providing me with two different amounts of total utility? I've got the same combination of the two goods. So that's just another way of kind of solidifying that, yeah, these can't cross, right? If they did, then I could have the same point representing a higher or lower amount of total utility that can't be. Okay? So the final kind of property we'll talk about, and it's pretty closely related to this first idea that I kind of gave you, which is that if I'm moving to different points on this indifference curve, not only will it represent that there's this negative relationship when I want more of the X good, I have to give up some of that Y good, but they're going to be bowed inward. So for example, think about if I'm moving initially from point A, if I want one more unit of good X, maybe because I don't have very much of it, I'd be willing to give up a lot of pizza, right? I don't need 18 slices of pizza. If I only have one can of Pepsi, I might want more to drink than I, want more to eat. So maybe initially to get one more can of Pepsi, I'd give up a large amount of pizza, right? 6 units or 6 slices. However, if I don't have as much pizza or I have a lot more Pepsi, well, now to get one more can, I'm willing to give up a lot fewer slices of pizza than I was before. Remember, as we have more of something, what's happening to the margin utility of that good? It's going down. We've got diminishing marginal benefit, right? So when kind of think about what I was doing here, how was I coming up with how many units of the Y good I was willing to give up? Well, it was really, how did I know that this was 6? I mean, before I didn't talk through it, I just kind of thought it was easy to see, like, if this is how much one more unit of good X gives me, this is how much one more unit of good Y, to have to give up 6 units of good Y. What was I really doing there? I was taking the ratio of the margin utility of X to the margin utility of Y. That was telling me, in order to get one more unit of good X, how many units of good Y would I have to give up? Or essentially what that's telling me here is the slope of my indifference curve. So the slope of our budget constraint, remember that represented if I want to be able to afford one more unit of X, how many units of good Y would I have to stop buying? Well, here, instead of being able to afford it, if I want to keep total utility the same, if I want to buy one more unit of good X, in order to keep total utility the same, how much of good Y would I have to give up? So it's a kind of a similar concept, but with the income constraint, that was our relative prices. With our indifference curve, it's going to be the relative marginal utilities. Okay. So initially, I might be willing to give up a lot. When I have more of that X good, well, what's going to happen to the margin utility of X? At these higher quantities, the margin utility of X is going to be lower than it was before. Right? The margin utility of Y is actually going to be higher because I have less of that good. And so now when I take the ratio, maybe now it's something like 40/20. Now I'd only be willing to give up 2 slices of pizza here. So the slope of our difference curve is going to tell us what we call the marginal rate of substitution, or how many units of good Y would have the same amount of total utility as one more unit of good X. Okay. So to get one more unit of good X, how many of the Y-axis good would I have to give up to keep total utility the same? Right? So ultimately, I kind of preview this, but it's going to be our relative margin utilities. Okay. And it'll be negative because there's always going to be this trade-off. If I want to keep total utility the same, I have to give up some of good Y when I'm buying more of good X, right? To keep total utility the same there. Okay. So why does this have to be true? It's because we're trying to, hold constant that total level of utility. Okay. So I think here, before we go to this example, I just want to kind of, well, I'll do this first and then we'll come back to this. So if we have this idea that our margin utilities are going to be, that ratio is going to be the slope of our indifference curve, We also can look at a graph and say, all right, visually, what is our marginal rate of substitution? It's going to be the slope of our indifference curve. Okay. So we don't have to use the margin utilities. We can also use the quantities. So notice here, if I'm moving from point A to point B, how much is the y-axis good going down by? I'm going from 5 to 3, so -2. I'm going from a quantity of the x good, Pepsi, of 1 to 2. So there, the change in the quantity of y over the change in the quantity of x would be 2 over -1 or -2. Or sorry, -2 over 1, -2. Now, as I have more of that x good, what should be happening to the slope? Well, there, if I want one more unit of the x-axis good, I should be willing to give up fewer units of the y-axis good. So if I'm moving from point C to D, I've already got, I've got more cans of Pepsi now than I did before. Well, now to get one more can of Pepsi, well, I'm looking here, the change is 4. I can think about this in a different direction, right? If I want 4 more cans of Pepsi here, how many units of good Y am I willing to give up? Only 1. So each can of Pepsi was costing me what? Change in quantity of 1 over the change in the quantity of 4, change in quantity of Y over the change in the quantity of X, or, oops, -1/4. So as I have more of that x-axis good, I'm willing to give up less, right? Before I was willing to give up 2 units when I had only 1 can of Pepsi. When I've got 3 cans of Pepsi, I'm willing to only give up 1/4 of a slice of pizza to get 1 more unit of good X or 1 more can of Pepsi. So our marginal rate of substitution is going to be decreasing, right? Or the slope of our indifference curve, it's becoming flatter. Okay. All right. I'm going to try to then kind of relate this, or show this to you in a slightly different context. If I can get my paper to move them. I'll do something here. So let's say, just as a kind of reminder, we had the quantity of X, quantity of Y. Last class, we looked at a budget constraint. Where did this come from? We took the total amount of income and that had to be equal to the prices of both goods times however much we were buying. All these different combinations told us these are all the combinations of these two goods where I'm spending all of my income, or I can afford them and I'm not wasting any resources. Okay. What did we say this slope was? Well, you can compute it by taking the change in what's on your y-axis, change in the quantity of y, over the change in what's on your x-axis, change in the quantity of x. We also said, because these intercepts, these quantities are actually a function of income and prices, sorry, price of x. We showed last class, so we can rearrange this. The slope also ends up being the relative price of good x to the price of good y. So we usually don't write this next equation out, and it's a little bit more complicated than this because prices were always the same no matter how much we were buying of each good. If we want to keep total utility the same, it's really like the margin utility from x times the quantity we buy of x plus the margin utility of y times the quantity of y. It's just that these have their own function, so the math becomes a little bit more complicated. That's why we don't have just a nice linear curve. Our indifference curves end up being kind of bowed inward, right? But it kind of comes from a similar idea. So the fact that we have this budget constraint, the slope we can compute using quantities, but it'll also be the same as our relative price of x over y. We can find the slope here, same kind of idea. I can take it, the change in the, quantity of y over the change in the quantity of x. But that will also be the same as the relative marginal utilities. Okay, so similar kind of ideas, just in, now we're not dealing with income as kind of what we're trying to keep constant. Now we're trying to keep constant that total utility, and it's not a nice linear curve because these margin utilities aren't one value. As we have more of x, this margin utility will be going down. Okay. So the goal, all right, now that we can kind of compute this marginal rate of substitution, is going to end up being, we want to get to the highest, higher indifference curves represent higher amounts of total utility. We want to get to the highest indifference curve possible. What are we constrained by? Well, the fact that some of those points, like why don't I just keep buying more of everything? Because we can't afford it, right? So our ultimate goal is to get to the highest possible indifference curve that our budget constraint will allow us to afford. Okay. Excuse me. Now, why would I not be below the budget constraint? Well, because there I wouldn't be spending money. I could be at a higher indifference curve, or I would have higher level of total utility than if I, just let my resources kind of lay around. Okay. Whoops. So here's going to be kind of a nice little summary, but I'll kind of go through and kind of build this out and solidify how we're coming up with this consumer optimum. Okay. You can think about it. If I have two goods here, here's my, let's just do 3 indifference curves. And they represent, as I get to higher indifference curves, higher amounts of total utility. Okay. Well, if I had a budget constraint that was down here, okay, what's the highest possible indifference curve I could get to? Well, it touches this indifference curve at one point. Every other indifference curve, if I drew in all the other ones, they would all be down here. These would be lower amounts of total utility. Why would I want to be on these curves when I could afford to get to this highest one? So whatever indifference curve, the highest indifference curve my budget constraint allows me to get to, that's the one that I want to be on. Okay. So I can kind of think about this as, okay, there's all these points here that are above my budget constraint. These would maybe be on higher indifference curves, but I can't get to those indifference curves because they're unaffordable. What could allow me to get to those points? Well, what if I had an increase in income? We looked at those shifts last class. So let's say, I don't know. I've got this increase in income, okay? Points that used to be unaffordable to me, I can now afford, right? They're below my new budget constraint. Okay? So this was like our first budget constraint. Now we're out here on our second one. Well, I definitely would want to spend, if I'm spending all of my money here, I could be at either point here. I'm on a higher indifference curve. I can now afford these points. So I definitely want to spend maybe out here. But these won't be the optimal points because what could I do? Well, there's still going to be indifference curves. It's not just these 3. We've got like an infinite amount of indifference curves. So if I was spending here, yes, I'm now at a higher level of utility, but I could afford an even higher amount of total utility. So I want to keep spending or changing my spending habits so that I am now somewhere on my new budget constraint, but the point I want to be at is wherever the highest possible indifference curve, the last indifference curve that I can afford. Okay. So what's going to end up being true at this point is our marginal utility per dollar we're spending is actually going to be the same for both goods. Okay. And I'll kind of walk you through why here in a second. Okay. But for now, we just know that where we're spending at an optimum, it's going to be that highest possible indifference curve I can afford to buy or given my budget constraint. Okay. So with this in mind, right, what's the slope of my budget constraint, or sorry, first I did the indifference curve. What's the slope of my indifference curve at this point? So I kind of try to draw this, but you can see it's equally tangent, right? This budget constraint is what we call tangent to this indifference curve, or they have the same slope. So that highest possible indifference curve I can get to will end up having the same slope as my budget constraint. So I've got my marginal rate of substitution at that point will end up being the exact same thing as my relative prices. Those are just the slopes of my indifference curve and my budget constraint. They'll be the exact same when I get to the highest possible indifference curve facing that budget constraint. Okay. So if we know this is true, okay, at that optimal point, I told you the marginal utility per dollar should be the same for both goods. Well, let's just start out with saying that marginal rate of substitution, or the slope of my indifference curve, is the same as the slope of my budget constraint. That's going to be true here. Well, there's technically negative signs here, but when I start to do the algebra and multiply both sides by a negative sign, this becomes positive. I'm going to multiply both sides by the margin utility of y. This cancels. Divide both sides by the price of x. This cancels. What am I left with? The margin utility of x over the price of x is the same as the margin utility of y over the price of y at that point. Okay. So our margin utility per dollar we spend, because we know the slope of that budget constraint and the indifference curve will be the same at that point, we can just rearrange that, and that shows us, oh yeah, the margin utility per dollar must be the same for both goods. Okay. Or we're getting the same bang for our buck. Right? Every dollar we spend on each good, we're getting the same total amount of additional utility. Okay. And we walked through examples just with like small quantities last class. This allows us to look at things that are a little more continuous. Okay. So before we do rotating budget constraints, I want to walk through why this will be true, just some further support to kind of thinking about the consumer's decision. Okay. So let's do quantity of X, quantity of Y. And let's do this guy here. So we've got our indifference curve, and we're just going to use 1. Okay. And then just to kind of have, well, we'll do this in the same color. Try to draw this so they just hit right here. Here's my budget constraint. Okay. Let's assume for a second, right, that I was at this quantity. That was where I was currently spending, right? So if I'm currently spending, or I currently have this quantity, what would be true? Well, first of all, I can't afford that point, right? But I could also think about why. So if I was down, oh, how do I want to show this? I'm like here, here's my other income. So given my budget constraint, if I'm right here, right, what's going to be true about the slope of my indifference curve, right, relative to the slope of my budget constraint? It's a little bit steeper. Right? So what that would mean is the marginal rate of substitution, if it's steeper, it's going to be greater than my relative prices. Once again, similar to last slide, I just rearrange these so that I multiply both sides by the margin utility of y, divide by the price. What this is really saying is the margin utility of x over the price of x would be greater than the margin utility of y over the price of y. Right? So this is just me rearranging this equation. Well, if the margin utility of good X is higher per dollar I'm spending, what should I do? I should buy more of good X. So what do they do? If I was at this point on a lower indifference curve, I start to buy more of the X good and less of the Y good, right? If I'm constrained by this budget, when I buy more of X, I have to buy less of Y. I'm going to continue to do that, right? The slope of my indifference curve would be steeper than the slope of my budget constraint until I get to this point where they're exactly the same. Right? And then once we rearrange that, we said that means the margin utility per dollar is exactly the same. If instead I was spending like at a point down here, well, what's going to be true there? The slope of my budget constraint, it's a little bit steeper than the slope of my indifference curve. Once again, I could rearrange this a little bit. So what this is really saying is that the margin utility per dollar of good Y is greater than the margin utility per dollar of good X. So what should I do? Buy more of good Y, which if I'm constrained by the amount of income I have, that means inherently I have to buy less of good X. So if we were currently spending at different quantities somewhere on our budget constraint, the fact that we know here on this area, the margin utility per dollar will be greater for good Y, we would want to buy more of good Y. If we're over here, the margin utility per dollar of good X was greater, we want to buy more of good X. no matter where we're at, that's going to push us towards this point where that incentive is only eliminated once we have the same margin utility per dollar being spent on both goods, which is the point where that budget constraint has the exact same slope as our indifference curve. Okay. Any questions there before I keep moving? Go back to the slides here. Okay. All right. So now that we can kind of think about where this consumer optimum is going to be and why, the next thing we'll think about is, well, what if we have changes in price? How is that going to impact where that consumer optimum is? So I've got one here that I think is a little bit easier. I'll then kind of draw in some other ones that might not be quite as easy. But let's say I had this pizza Pepsi example. What if my original budget constraint was this kind of like light purple line? And with that budget constraint, the highest possible difference curve I could get to would be at this quantity of 4 cans of Pepsi and 3 slices of pizza. Well, if I see a price increase, Pepsi goes from $1 to $2, intuitively, if the price of Pepsi goes up, what am I going to be more or less likely to buy? Less likely to buy Pepsi than I was before, and more likely to buy pizza. Now, this is an example where we can see once that price goes up, if I'm only buying Pepsi, I can afford to buy less of it. So the slope of my budget constraint has now done what? It's gotten steeper. So I'm going to end up on a point that's higher on this indifference curve. But also notice when I have price increases, there's all these combinations that I could afford before, I can no longer afford. And the old consumer optimum would be one of those points. So where does my new budget constraint, what's the highest possible indifference curve I can get to with that budget constraint, would be somewhere at a lower level of total utility. So after that price change, the consumer optimum moves from what? 4 and 3 to 2 and 3. So I buy less cans of Pepsi when the price goes up. Here is an example where I kept buying the exact same amount of pizza. We'll complicate this here in a second, but just introducing the idea of you can draw these changes to your budget constraint in and think about how it's going to change your consumer optimum. So I've got 2 slides left open for slightly more difficult, right? And I'll kind of walk through this. So the very first one, and I really already did this for you a little bit. We were looking at like, well, how would I get to a higher indifference curve? I have to have more income. Oops. So the question was why the grades changed. So I changed the grades on 5 and 6 because there was one question that only had like, was worth 1.25 instead of 1.5 points. If you want further explanation, I can explain to you at the end of class. So let's think about, oh, you're fine. Oh, if I can get this out of the way. All right, so we have, let's say my income is here. My budget constraint, here's my indifference curve. Here's my consumer optimum, where that budget constraint is tangent or has the same slope as my indifference curve, right? What did we say is going to be true here? That margin utility of X over the margin utility of Y is the same as the price of X over the price of Y. Okay. If I have an income change, and here we're going to say an income decrease, well, what's happened to this slope? The relative prices actually haven't changed, right? However, I can't afford to buy as much as I was before, right? All these points are now unaffordable. So what will end up being true is if you have an income decrease, you know that you're going to end up on a lower indifference curve. So I try to put the value like being 50 units of utility here, where we can think about, well, what would this be if these were both normal goods? We talked about the effect of that income decrease should be that we bought less of good X and we bought less of good Y. Okay. And we'll do inferior goods at the end. For now, we'll just kind of treat our models with normal goods. That kind of simplifies them. We got to walk before we can run. Okay. So income changes are kind of easy because we've kept the relative prices the same. Prices haven't changed, right? So if I have less income, I'm going to be able to afford to buy fewer of both goods. If I have more income, I can now afford to buy more of both goods. Okay. So the income effect just has an effect. There's only one effect. What we're going to end up seeing with price changes is there's actually multiple types of effects that occur. So I'll kind of walk us through an example here. So let's say, oh, and we did a price decrease. So let's do, or we did a price increase in the other example. So let's do one where we've got, here's my first budget constraint, and here's my first indifference curve. Okay. And here's the optimal point, right? So I'll kind of say this is first quantity of Y, first quantity of X. Okay. Let's say that the price of good, oh, we can do this on either axis too. So let me make the point here. Let's say the price of Y goes down. Okay. The price of Y goes down. If we're only buying X, we can afford to buy the same amount. But if we're only buying Y, we can now afford to buy more units, right? So our price decrease, remember, like kicked up whatever intercept of the good had that price change. So you kind of notice if I keep spending where I was at before, I'm at a point that's below my new budget constraint. I could afford to get to a higher level of total utility. Right? So we can kind of think about here, facing these new prices, I can actually now get to a higher level of total utility. Okay. Now, it could be the case that when the price of Y went down, I keep buying the same amount of good X. But notice if the price of Y goes down here, I find, oh yeah, I'll buy more of good Y. Okay. So even though this is kept the same, right, we have two types of effects that occur when we see a price change. So the first is going to be probably the easier one, the substitution effect. If the price of Y goes down, what do I want to substitute away from, or what do I want to substitute towards? Well, whatever good is now relatively cheaper, I want to buy more of that. However, if I'm on kind of the same, budget constraint, I'm going to buy less of the other. I have to buy less of the other good, right? So I want to substitute towards whatever has a lower price. Now, the income effect is our second effect, which is when I see a change in prices, we don't care just about income, okay? So in fact, when I was drawing, if I can get it, the income shift earlier, this technically wasn't just a shift in income. What did we say last class could have caused this? Maybe I have the same $100 in my pocket, but if the price of both goods went up kind of the same amount, same proportion, that would look like a change in income. So what we really care about is not just a change in income, but a change in our real income. And real income is just take our income and divide it by prices. Okay. So when the price goes down of any good, what's happening to our real income? Well, this entire fraction would be going up, dividing by a smaller value. So if I have two normal goods, if this price decrease caused me to have more real income, what would I actually do? Buy more of both goods. Okay. So because these effects happen simultaneously, when we observe these two like final points, call it point A and point B, this is going to represent our total effect. We'll talk about in a second how we can visually decompose that into the substitution income effect. But for now, thinking about these two consumer optimums, the difference between those is just our total effect. Well, now here, we definitely know that the consumer is going to buy more of good Y when the price goes down. But how much more or less do they buy? We don't know. It depends on if that substitution is greater than the income effect. In fact, I tried to draw it as best of my ability here. What can happen? These two could be exactly the same. So we don't know what's going to happen to the quantity of X. It could go up, down, or stay the same. It depends on the relative size of that income and substitution effect. Okay. So I'm going to use like this shorthand to decompose our price changes into a substitution income total effect. I'll also kind of give you some visuals in the slides here now. Okay. So we kind of just walked through income, price changes. Let's now kind of think about these two different types of effects and how we can look at those visually. Okay. So the substitution effect, right? I think once again is intuitive that we're going to buy more of whatever is relatively cheaper or less of whatever is now relatively more expensive. The real income effect, when prices go up, that's like a decrease in real income. So everything, if it's a normal good, is going to experience somewhat of a reduction in quantity. Okay? We just have, our same $100 in our pocket can buy fewer of everything, right, when prices are higher. So let's think about this pizza Pepsi example. We'll kind of put some different numbers to it, but let's say, and it could be or soda. I said Pepsi, soda, pizza to make the subscripts easier. So let's say we start out, price of soda is $4 a can, slice of pizza is $1. Whatever this consumer optimum currently is, maybe this is over the year, 600 slices of pizza, 150 cans of soda. Let's say the price of soda falls. Okay, so here we've got a price decrease, but now it's the good that's on my x-axis. So I can do this for either good, right? Whether it's on my x or y-axis, doesn't matter. And I'm going to get the same implication. So the total effect would be that once I draw in that price change, how it impacts my budget constraint, where is my new consumer optimum? Right? So here I've got that the total effect is when the price of soda went down, I bought 100 fewer slices of pizza and 200, went from 150 to 350, 200 more cans of soda. So that's my total effect, but I can break this down into the substitution and income effect. Okay. So let's go back and assume that I'm starting out at that initial consumer optimum. When the price falls, I know my new budget constraint should be out here. But before I identify my new consumer optimum, I'm going to think about if I was able to if I was spending in a way where I kept my total utility the same. So let's say I could only afford to buy the same level of total utility I was before, but I'm facing these new relative prices. So the new slope of my budget constraint after that price change, but I'm assuming away the income effect. I'm assuming I could still only afford to buy the same amount of total utility. So by staying on the same indifference curve, but looking at the difference in the relative prices of my budget constraints after this price change, well, what's the only thing changing is my relative prices. That's going to represent my substitution effect. Okay. So moving from point A to point B, we can see, oh yeah, I'm going to buy less of the y-axis good because the x-axis good is what saw the price decrease. I want to buy more of that. So moving on the same indifference curve, but facing our new relative prices, that's going to represent our substitution effect. So B is kind of like this hypothetical in-between point that we don't actually observe in the data. Okay? And I know I say observe wrong or observe weird sometimes, so I apologize. But it's my vernacular. I don't know. I've got my own. I don't know. I don't know where my accent. It's not an accent, but my weird way of pronouncing words comes from sometimes. Okay, so instead, if we think about moving from point B to point C, that's facing the same new relative prices. Now, this dashed line is kind of like a hypothetical budget constraint. It's like, what if our real income didn't change, but our relative prices did? So same relative prices, but now we can afford, given our new real income, price went down, so our real income went up. Well, look, it's a parallel shift. This looks like an income shift. So going from point B to point C, same relative prices, shut down the substitution effect, but we can afford to buy a higher level of total utility. That's just going to represent our income effect. Now notice for both of those goods, we buy more soda and we buy more slices of pizza, more of both. What's the total effect for pizza? Well, kind of notice there was this huge substitution decrease, income increase that kind of offset it. The total effect moving from point A to C is we only bought a little bit less pizza, right? But both the substitution and income effect, we're pushing soda up. So that's why we definitely know for sure we're going to see an increase in the quantity of soda there. Okay. All right. Excuse me. So just to kind of point some things out, when we're talking about the substitution effect, we were saying that's like using this hypothetical budget constraint, moving on the same indifference curve, but to different relative prices. Well, those relative prices also tell us something about the marginal rate of substitution between the two goods. So you'll notice when I've got complements, or sorry, when I have substitutes here on the left, well, there, if I face different relative prices, small changes in the relative price could cause large changes in the quantity. I substitute quite frequently. I view both goods pretty similar. So when one is cheaper, I buy a lot more of that. If they're complements, that's actually going to mean that we have kind of like, there's having more of one good. I kind of want to have more of the other as well. Otherwise, it doesn't really benefit me. So I chose what? Hot dogs and hot dog buns here. So there you could see the substitution effect is going to be a lot smaller. So same change in relative prices, same change in slope here, but it's caused a much smaller change in that quantity of X, right? And in the quantity of Y. So how strong of substitutes or complements two goods are will dictate how large those substitution effects can be. I'll talk more about this probably at the beginning of next class. If we have time at the end of the class today, I will. It's going to be stuff that I don't ask you questions on in this quiz that I'll post after class today. So I'm going to kind of reserve some time, push this off and go through things I know will be on that quiz. Okay. So we'll come back and revisit these idea of perfect substitutes and complements to kind of solidify this effect if we have time at the end of class, or we'll start class with it tomorrow. Okay. So instead, we'll skip ahead a little bit and we'll think about how I could take an example that I have visually and do it shorthand, right? So here I've got an example where let's say we're starting out and this is our budget constraint, right? The highest possible indifference curve we can get to is this one here at point C. So we can decompose this into two types of effects. So what did we see here? Well, if after this change, we saw that the budget constraint kind of kicked out, or we can buy more movies, it must have been that the price of movies was going down. So I could shorthand this without a visual. Think about, I've got two things. I think it was soda. I was really into soda when writing this module, and then movies, right? So if the price of movies went down, we know that's going to do what in terms of our substitution effect? Means that we're going to buy more movies, fewer of the other good. What about our income effect? Well, what impact does price decreases have on our real income? We said real income is like income over prices. So if prices go down, real income goes up. My income effect, if I have two normal goods, would be that I buy more of both of them. So what is my total effect going to be? Well, I know for sure the quantity of movies will go up. I don't know about the quantity of soda. It's going to depend on the relative size of that income to the substitution effect. So if we looked at our visual, what tells us the substitution effect? Well, that's when after we see this price change, if instead of going to the new consumer optimum, where that new budget constraint is on the highest indifference curve, if we were only able to afford the same level of total utility as before, but we're now facing the different relative prices, so that curve that has the same relative prices or as parallel to our new budget constraint, we'd be down here at point K. So moving from point C to K, we're affording the same level of total utility, but we're looking at, different relative prices. That's only we've shut down the income effect. We're only looking at the substitution effect. So it looks like I buy what? 3 fewer sodas and 2 more movie tickets. So the substitution effect was I bought 3 fewer sodas, 2 more movie tickets. Now the income effect was when I have the same relative prices, this hypothetical budget constraint, and then the final, new budget constraint. So I've kept relative prices the same. I've shut down the substitution effect, but I can now afford to buy a higher level of total utility because when prices go down, my real income goes up. So moving from point K to point J, that's going to represent my income effect. Notice I buy one more soda, two more movies. So one more soda, two more movies. What should the total effect in this example be? Two fewer sodas, four more movies. And in fact, if I look at the movement from my initial consumer optimum to the new one, I bought two fewer sodas and I bought 2 to 6, four more movies. So you can always take the visual of the graph because it does get complicated. I understand why this is tough. We have like this hypothetical budget constraint. We're shutting down the substitution effect by keeping the slope the same here, shutting down the income effect by affording the same amount of total utility. You can always kind of use the shorthand as well. Okay. So we've got a couple different scenarios. So the ones that we've really worked through these examples are these normal goods. So everything I've done up to this point, we're assuming that the income effect has been acting as though the goods were normal goods. We can also have inferior goods as well. Okay. So I'll go through a shorthand example of this in a second, and I'll also kind of show you some visuals. Okay. So if we have these inferior goods, we're going to end up with two scenarios. One is that the substitution effect is greater than the income effect, and their price and quantity move in opposite directions, kind of like we would think, right? If the price of X goes up, we end up seeing the total effect is that people buy less of it. However, there's this weird scenario, we call them Giffen goods, where you can actually end up with a price increase decreases the total quantity. So I'm going to give you the shorthand behind why this can occur, and then we'll kind of look at some visuals. So let's say I've got two goods, and well, here, we'll do X is going to be our inferior good, Y is going to be our normal good. Okay. If the price of X goes up, excuse me, then what is my substitution effect? Well, that's just going to be I always buy less of whatever has a price increase, more of whatever is now relatively cheaper, right? The price of Y hasn't changed, but the relative price has changed. What impact is a price increase going to have on our real income? Well, once again, real income is just income over prices. If prices go up, real income, I'm dividing by a larger number, is going down. So what is our income effect? Well, if X is an inferior good, when I have less money, what will I do? I'll actually buy more of it. So this is an example where this class isn't cumulative, or sorry, like the exams aren't cumulative, but we're using old principles. I'm assuming you still have an understanding of the old principles that we've covered. And then for a normal good, when real income goes down, people would buy less of good Y. So what is our total effect? Well, this is actually a scenario where I don't know the total effect for either of these, right? It depends on, is the substitution or the income effect larger, right? So we would kind of say, I don't know, right? And in fact, if that income effect for good X was greater than the substitution effect, what would be true about the quantity of X? Well, if the income effect is larger, it's going to be the one that wins out, or like has, like I think about if it adds 10 and this only goes down by 5, there I could see the quantity of X, the total effect is that it actually goes up. So if X becomes more expensive, I actually buy more of it. It seems like this counterintuitive result, but it's because of, it's not just the income effect that's occurring. We also have kind of this substitution effect going on. But if that income effect is so large, like if I'm spending a large amount of my money on this inferior good and the price goes up, it might impact my real income so much that I have to buy less of all these other normal goods, and I'm forced to buy more of this inferior product. Right? So I don't know. This could be something like low quality or low income like housing, right? If low income housing becomes a lot more expensive, people they would love to not have to buy more of it, but because it forces their real income, like real estate prices go up, I might not be able to buy, a house now. I might be forced to kind of rent these lower income or lower quality apartments or homes. Okay. So that can occur. If that does occur where the income effect is larger, we would call that a Giffen good. So I have kind of two visuals of this. So this is why I updated the slides as well. So here's kind of the first one. It's kind of an extreme example, right? So let's say I I originally started here. I've got what? I've got some really cheap whiskey. I was at the liquor store the other day, and this is like the cheapest one. I also this distillery in Indianapolis. I love their whiskey, Hotel Tango. Once you're 21, definitely go there. They've got great stuff. They got more than just whiskey, but that's their best stuff. So let's say I'm originally kind of facing this orange budget constraint. Right? A is going to be kind of where that point hits my indifference curve. Now, the indifference curves look kind of weird when we have these Giffen goods, so that's why these look kind of odd. If I then saw a price decrease in this cheaper whiskey, right, this inferior product, well, it shifts my budget constraint up. So if I'm looking at the new relative prices, but I could only afford to buy the same amount of total utility I was before, and here I didn't realize these didn't shift with my curve. So just here's difference curve 0. So that's kind of where we're starting out. And here's our new indifference curve. There we go. So keeping the relative prices the same, but still only being able to afford the same amount of total utility as before the price change, I'd be down here at point B. So it looks like the substitution effect, okay, yeah, I do. I buy more of the good that had a price decrease, less of the good whose price didn't change because it's now relatively more expensive. But if I think about moving from point B to point C, that's going to represent the same relative prices, but now I can only afford to buy, or sorry, now I can afford to buy a higher amount of total utility, right? I'm moving to a higher indifference curve here. So the income effect is going to be I actually buy more of the normal good, but I bought less of that inferior good, right? Price went down. We know real income is going up. So if my real income goes up and I buy less of something, that tells me it's an inferior good. In fact, that income effect was larger than the substitution effect. So if I think about moving from point A to C, that's my total effect. I'll see that even when the price of this x-axis good went down, the total effect is I actually bought more of the y-axis good and less of the x-axis good. So this is going to be a situation where we have the income effect being larger than the substitution effect, so that the total effect is the price and quantity move in the same direction, which seems like it breaks the law of demand, right? But it's because we're not just looking at one good now, we're looking at the consumption of multiple goods at the same time. So here would be an example of a Giffen good. Okay. Now, what is more likely to be the case? Let's say I had a scenario that looked like this. So now I've got movement from point A to B would represent, okay, yeah, when the price went down, I had this substitution effect where I bought more of the good that was cheaper, less of the good that was more expensive. But the income effect, even for inferior products, likely isn't going to be that large. So prices going down causes my real income to go up. So for the inferior good, I bought like just a little less, right? Movement from B to C, I barely bought, just a little bit less of this inferior good. I bought more of the normal good. Here, what's the total effect from A to C? Well, when I saw a price decrease in this good, I actually ended up buying more of it. Right? So this would not be a Giffen good, right? When the total effect kind of lines up with what we were thinking about for our law of demand, that's where we don't have a Giffen good. Anytime that income effect is greater than the substitution effect, price and quantity for that good will move in the same direction. That kind of seems like it goes against our law of demand. That's going to be our Giffen good. Okay. And these are difficult to draw by hand, which is why I'm relying on the slides here. Okay. Any questions on that before we keep moving here? So I would say you want to be able to identify these movements on a graph, but a lot more important is probably when you're looking at these practice quiz and exam questions, a lot more of being able to solve these types of problems by hand using that shorthand, using the arrows. So I'll go through one more example. I think we'll have time here after we go. And actually, it'll kind of be part of this participation quiz for the day. So we'll open this up. We still got 15 minutes. We've got plenty of time. So also make this point, when I'm going through these, the order that I see them in, it shuffles answers. So you might see them in a different order. So this is like a way for me to make sure people are paying attention when they're here live, but also if they're watching the recording. So be careful as I'm going through these, make sure we're clearly figuring out which one is the right answer here. So if I've got these indifference curves, A, B, and C, first of all, which one represents the highest amount of total utility? Well, it's going to be the curve that's furthest away from this 0, 0 point. So indifference curve A is the highest amount of total utility, B is the next highest, C is the next highest. Okay. So what is the linear curve in the middle here? Well, that's going to represent all the combinations of these two goods I can afford to buy. So point F, G, I, K, and L are all different points that I can afford, right? Points G, K, and H, they're all points on the same indifference curve. So that would represent different combinations of those two goods that would provide me with the same amount of total utility. Okay. So which of the following is going to be true? So point I and J are unaffordable. If I look at point I, that is on my budget constraint, so I can afford to buy that. Point J is above that, which means every point above my curve are combinations of these two goods I can't afford. Okay. So that one's not true. What about G provides a higher amount of utility than point J? So I'm looking at point G and point J. Being on a higher indifference curve is a higher amount of total utility. So being out here, J is actually a higher level of total utility than G. So this is like flip-flopped. H and K are using all of an individual's income. Well, all of my income would be if I'm spending at a point that's on my budget constraint, right? So K is on my budget constraint, but H is not, right? I still would have enough money to afford to buy more of both goods or spend up to I. So that one's not true. J provides a lower level of utility than H. So J provides a lower level of utility than H. Indifference curves further away from 0, 0 represent higher amounts of total utility. So that one's not true. H and G provide the same amount of total utility. Well, here, if I'm on the same indifference curve, even though G, I'm using all of my resources, H, I'm not, they're still providing me with the same amount of total utility. So that's going to be the one that ends up being true. Now, that won't be my optimal point. What's the optimal point is to get to the highest indifference curve, B, that I can afford given my budget constraint. So that would be kind of point I. Okay. So the one that is true is that H and G, since they're on the same indifference curve, provide me the same amount of total utility. Okay.
Just so you know, Professor, your screen is not being shared right now.
Oh, sorry. Thank you. Should have said something. That would have.
Yeah, sorry, I messaged you. I just didn't
Oh,
want to interrupt
you're
while
okay.
you're
I didn't see
talking.
it pop up. I didn't realize I had it switched over the wrong way. There we go. Now you can see this one, right? So,
Yep.
sorry, I'll go through that again quick. So I and J, J would be unaffordable because it's past our budget constraint. I is on it, so it'd be affordable. So they both can't be unaffordable, right? I is on our budget constraint, it is affordable. So that one's not true. G is a higher amount of utility than J. Well, the further away we are from this 0 point, A would be the highest possible difference curve, B the next highest, C is the next highest. So J is actually a higher amount of total utility than J, or G, whatever. J is higher amount of total utility than J. They're not the same amount. H and K don't represent where we're using all of our income. They represent points in the same indifference curve, so we have the same total utility, but K is on my budget constraint, so I'm spending all of my money. H, I'm not on that budget constraint, so I still have resources to spend. Okay. And then J would be a lower level of utility than H. Well, as we move further from this 0, 0 point, higher indifference curves represent higher amounts of total utility. So J is actually a higher amount of total utility than H, right? So that one doesn't make sense. This says J is a lower level. So the one that has to be true is that H and G are providing me the same amount of total utility, right? Because they're on the same indifference curve. Now, G, I'm spending all of my resources. H, I haven't spent all. So just because they're on the same indifference curve, I can still spend a little more money to increase what amount of total utility I can get to. So point I can increase my total utility and I can still afford it, right? So I and G would both be affordable, but I puts me on the highest possible level of utility. G and H are where total utility is the same, but H, I haven't spent all of my resources yet. So that's why kind of H and G providing the same amount of total utility should be our answer there. Okay. Questions on that before I keep moving? All right. So what if we had a question like this, right? So I kind of reused a slide I had earlier and then drew in kind of the in between. So let's say I'm going from this point of 4, 3, right? And budget constraint 1, so I'm starting out with this budget constraint. I see this price change. Now, if the amount of Pepsi I can buy has decreased, but the amount of pizza I can buy has stayed the same, this new budget constraint, BC3, must be that I saw an increase in the price of this x-axis good or an increase in the price of Pepsi. Okay. So as a result, right, the new optimal point where my new budget constraint hits this highest possible indifference curve is at this point of 2, 3. So here's an example where the total effect is actually I buy the same amount of pizza, right? But the total effect on Pepsi is I went from 4 to 2 or bought 2 fewer cans. How can I break this down into my substitution and income effect? Well, moving from this point of 4, 3 to A, so it's a slightly different way of looking at it than we did before. Moving from point 4, 3 to A, I've got this new hypothetical budget constraint 2. It's got the same slope as my original budget constraint, so I'm keeping relative prices the same. If I keep relative prices the same, what have I shut down? I've shut down the substitution effect. So moving from this budget constraint, 1, to the hypothetical budget constraint, 2, because they have the same relative prices, the only change there is occurring from the fact that I have less real income when that price went up. So moving from 4 to 3, 4, 3 to A, that's representing my real income change, right? Or my income effect. Now, if I think about moving from point A to point 2, 3, there I'm on the same indifference curve. So this is saying if I could afford to buy the same amount of total utility, so I'm assuming away, I'm shutting down the income effect, but I'm facing a different sloped budget constraint than I originally was. So budget constraint 2 is the initial relative prices. After the price of Pepsi went up, here's my new budget constraint 3. That difference in the relative prices, but assuming I can afford the same amount of total utility, movement from A to 2, 3 would represent my substitution effect, right? So there, that first one, movement 4, 3 to A is our income effect, right? We're keeping relative prices the same, but not able to afford as much utility. Keeping the amount of total utility we can afford the same, but facing our new relative prices, A to 2, 3, that would be our substitution effect. Okay. So let's make sure. I think we've got those in there. Yeah, we got 2 points for this one. We've got 2 points for this one. Okay. Any other questions there before I keep moving here? Okay. Just to kind of keep you consistent or at the same point as the other class, we'll talk more about this kind of deriving the demand curve, and we'll go through very quickly substitutes and complements at the beginning of tomorrow's class. But before we end class today, just to kind of give you another, I don't know, example of how we build these out, just to kind of help, I'll kind of draw a graph out and do the shorthand at the same time. So let's say I initially have, here's my budget constraint. Here's my first indifference curve. And we're starting out here. Nope, this is Y. Okay. So let's say I've got what's something we didn't do? Let's do a price decrease in good Y. Okay. Or no. I want to do this. I don't think we did an increase in Y. So if I have a price increase in Y, it's going to look something like this. So I'll do a dramatic one just to kind of make it. Right? So if I'm only buying Y, I can buy less, but no change if I'm only buying X. So the total effect is always, I think, an easier one to think about because it's going to be, okay, facing these new relative prices, what's the highest indifference curve kind of I can get to? Well, we can see here that the total effect of this price change was I bought less of good X and, oh yeah, I actually bought less of both goods. Right? So I should inherently know what the substitution effect was. I should know that when the price of Y goes up, I'm actually going to buy less of good Y and more of good X. Okay. So the only other effect I have here is the income effect. What must have been true about the income effect for good X? Well, if the substitution effect is I buy more of it, it has to be that the total effect is I bought less. It must be that income effect was pushing the quantity of X down, and that the income effect was larger than the substitution effect for good X. Okay. Sure enough, how can I look at that visually? Well, I can say, okay, what is my income effect? It's if I had the same relative prices. So what do we want here? We want, make sure I get this drawn in here, right? Hold on. Yeah. Well, should have brought a ruler. So you can kind of think about like this hypothetical budget constraint is where I can only afford to buy a lower level of utility, but I've faced the same relative prices. So it could be something like right here. So notice this is like my hypothetical in between point. So we can kind of see here my quantity of X hypothetical and my quantity of Y hypothetical. As I was moving, same relative prices, but able to afford a lower amount of total utility, the movement from here to the initial point to the hypothetical in between point, that represents, well, I've shut down the substitution effect. That should purely be my income effect. So notice that's saying I buy less of both goods, right? Now, what was the substitution effect? That's moving from that hypothetical point to the final point. So movement from here to here, I was actually buying a little bit more X, but even less of good Y. So you can see the substitution income effect, we're both pushing the quantity of Y down. Income substitution effect, we're pushing quantity in opposite directions. But notice that initial income effect was very large. The substitution effect was relatively small. And so what is the total effect going to be? Whichever of those was larger, which here we had was our income effect. Okay. Any questions on that before we keep moving? And then an additional follow-up could be, is this a Giffen good? Well, a Giffen good is only when the total effect from a price change doesn't kind of line up. Well, here, I didn't have a change in the price of good X. I actually had a change in the price of Y. Oh yeah, price and quantity are moving in the same direction. This wasn't even an inferior good, because in fact, when I had, what would this be? My real income is going down. What do I actually have in both cases here? Oh, I have normal goods. The only way I have a Giffen good is if I had this be an inferior good. Okay. So just another example, kind of walking through this. Next class, we will, oh, and there's a question there. Let me make sure I answered it. I'm not sharing my screen. Was that earlier during the quiz, hopefully? Because I wasn't supposed to be sharing my screen
Yeah,
there. Hopefully
that
you're
was
able
from
to.
before.
Okay, just making sure. So that should kind of do it for us here today. This perfect substitute, perfect complements, that's not going to be on the quiz. I will cover at the beginning of class tomorrow, so you would be expected, whatever we go through tomorrow, to know for the exam. But we'll go through it relatively quickly. We'll then jump into Module 9. That's all about firms' costs. So this was all about consumers spending, consumer optimum spending habit, or optimal decision. We'll be looking at the firms during the next two classes. Okay. So if there's no other questions, I'll kind of end the recording and then leave it open if you have questions you want to ask afterwards.